Hello, my name is Ehab. I'm part of Team 1, along with Brian, Perkay, Chester, Robert, and Samuel. On this report, we're going through the analysis and redesign of a Weber portable propane grill. So this portable grill provides a lightweight, convenient alternative to conventional stationary grills. The grill feature component can be also easily disassembled for cleaning. So this grill provides a room for cooking up to 9 burgers at once, and the estimated annual volume of the portable propane grill is 100,000 units per year. On this project, our primary target customer are the campers, and the secondary customer group here is the food caterers who move around from site to site and need a mean to prepare food fresh as they serve their clients. On this slide, we're showing the exploded view. So starting from the picture on the left-hand side, top to the bottom, so we start with the top shell assembly, the grill grade, burner, and the bottom shell assembly, including the igniter and regulator. And on the bottom, you can see the two legs that we have and the leg braces. On the picture on the right-hand side here, you can see the complete assembly where every part in its place. According to the functional analysis, cook food is our main primary function, and in order to do that, we need to contain food through support food and isolate food, and we need to add heat through distribute the heat and convert energy, and we need to control temperature through contain heat and control energy input. We also need to assure dependability by preventing burns, and this can be done through maintain control, isolate heat, and access food. Assure convenience through maintain position, enhance portability, and facilitate cleaning, and enhance products through add comfort, and also add place senses.
Through our analysis and review, we identified two feasible assembly sequences for our product. Both assembly sequences begin with the lower shell, as it's the main component for which others are joined to. The first sequence starts with the installation of the handle subassemblies, followed by the internal components, legs, and finally the upper shell assembly. The second assembly sequence begins with the installation of the legs, followed by the internal components, and is finished by installing the handle assemblies, and finally the upper shell assembly. Shown here, Sequence A scores well for the ease of handling and transferring parts, as well as locating parts on each subassembly. For Sequence B, there's a diminished score for the highlighted components in the areas of ease of transfer/handling, locating parts, and fastening and joining. This is due to the space restrictions that occur with the earlier installation of the internal components.
This slide contains the function component mapping matrix. The matrix shows the relationship between the individual components derived from the BOM and the basic functions that were the end nodes of the FAST diagram. All of the components serve multiple purposes. Notably, some functions such as maintain control and enhance portability are influenced by many individual components. This may indicate that these functions were an important consideration when designing the grill.
This slide shows the bill of materials for the portable grill we are using for preliminary cost estimation. We assume 100,000 units are being produced annually, and assembly cost is a combination of times for manual assembly and a wage of $15 per hour. For purchase subassemblies, the typical retail cost was used in place of material costs, and production costs were neglected. These assumptions were used for the igniter, the gas regulator, and all fasteners. The total unit price of this item is $35.50, which is about 50% of the typical retail price. The following two slides discuss our proposals for redesign. To reduce the total number of parts and increase ease of assembly, we propose consolidating the handle into one piece with 0 additional fasteners as seen in the picture to the right. By doing so, the total fastener part count is reduced by 18, and there's a potential cost savings of $5.77 per unit. Another proposal is changing the material type of each handle from stainless steel to PP plastic. The material cost of the handle will be 15 times less by implementing this change. Finally, we decided to eliminate the leg brace component because of its low-high location on the quad chart and replace it with an added feature on the bottom shell. This would result in one fewer parts as well as a cost savings of $1.10.
As you can see from this slide, the differentiating functions for our customer groups are contain heat, distribute heat, and access food. The common platforms for each product variant are the grill grate, gas regulator, bottom shell, support leg, igniter, and leg brace. The modules that support each differentiating function are the handle cover tops, handle cover bottoms, handle base, top shell, and burner. This slide depicts the two product variants for each customer group. The primary customer has one burner, whereas the secondary customer has two burners for higher cooking temperatures and an easy access handle at the front of the cooking box. The interfaces between each variant are common between all platform and modules.
Here you can see our product family assembly sequence for assembly sequence A. As you can see, the two product variants are differentiated once the burner is installed at the fourth step. This means that the product variants are differentiated relatively early in the assembly sequence, which is not great. Here you can see an improved assembly sequence. We decided to move the burner installation down to step 8 in order to delay differentiation. This means that for the majority of the assembly sequence, both product variants can be assembled in the same way. No part modifications were needed in order to delay differentiation.